Okay, we're also going to look at another way of combining functions. Instead of doing both simultaneously, as we did when we added or subtracted or multiplied and divided, we're going to do them sequentially, meaning one immediately followed by the other. This actually makes more sense in applications because traditionally we don't do two things at once. We do one thing, then we do another thing. Okay? And it's a little bit harder to understand what's going to happen when you compose functions. I like to think of it as putting on your shoes and socks in the morning. First you put on your socks, then you put on your shoes. And the combination is better than either of the parts individually. Okay? Now, the notation is this little circle. It's read f of g, and make sure that it's an actual circle and not a dot, because that looks like multiplication. And the definition is that f of g is f with g plugged into it. Now that seems a little bit weird, so we're going to do an example that will help us understand it. But there's one other thing you have to be careful of with composition of functions, and that's domain. When you're doing the domain, just like when we did the domain of f plus g and you had to look at both f and g, you have to look at two different things, but they may not be what you expect. So for the domain, you look at the domain of the inside function, which in our standard notation is g, and then you're going to look at the domain of the end result, what you get after you do the composition and clean it up a little bit. Okay, so we'll see what that means in our example. Let's first compute the composition. So I want f composed with g of x. And the definition tells me this is f of g of x. Now, when we did function notation, anytime we have f of something, whatever in the parentheses is what I replace x with. So I'm going to write down f, but instead of putting the x, I'm going to replace it with the thing inside the parentheses, the g. Okay. Now, this doesn't look very pretty, and since we happen to know what g of x is, I'm now going to go through and replace that g of x with what it equals. Okay. So this is the composition of the functions, but we would like to clean it up a little bit. So first we note that a square root squared cancels each other out. And then 4 minus 1, of course, is just 3. And that is our end result. Okay. Looks nothing like either of the two original. Now we're going to compute the domain of this composition. Okay. Now, to start with, I would like the domain of both f and g. The domain of f, well, we notice that x cannot equal plus or minus 1. The domain of g, we notice that x needs to be bigger than or equal to -4. Okay. Now, let's look at the domain of the composition, which we do by looking at two things. The domain of the inside function, which in this case is the domain of g, and the domain of the end result. So I go down here to the end result and I say, what's the domain? And the domain is everything but -3. So I'm going to take this together with my domain of my inside and look at their overlap. So I need things bigger than -4 but can't equal -3. So I want everything from -4 to -3 and then from -3 to infinity. And this is the domain of the composition of functions.